Okay, so the reason you want that guard working is if you were one of those guys that pull the saw away from your work while it's running, where does your arm allow the saw to go? Right in your leg. And if you would be so unlucky to hit your femoral artery, you only have a couple minutes and you're dead. Okay? So make sure you're one of those guys that keeps the saw in your work until it comes to a complete stop. Keep both hands on the saw. Kind of hard to cut your hands if both hands are on the saw. Right? Now there's occasions you may use one hand, but the safest procedure is to have two hands on the saw. Okay, adjust the depth. Adjust the depth for the thickness of the material you're cutting. How thick is this 2x4? I think I heard it. 1.5 inches. You are right. So if I was to go 1/8 to 1/4 beyond that, what would I set my saw? 1.5 inches plus 1/4 is 1 3/4. So I take my tape measure, run my tape measure, run the blade. Right now it's cutting 2.5 inches. That means I would have it. What's that?
6
Yeah, 1 3/4. Okay, so that's what I'd want to set it at. Okay, so right now I have an extra inch of saw blade. When you're out as a real carpenter, you probably are going to be in the mode of get it done, get it done, get it done. And you're going to rarely set the saw. Okay, the reason you want to set the saw is if something happens, there's less blade to cut your fingers off. Okay, if it's only sticking above 1/4 inch, you might just get flesh and not tear up the bones. Okay, but you'll see a lot of carpenters out there, maybe not so much that they're too lazy, it just takes time. And they're just always in a hurry. So we want to be safety first. How to adjust this saw for depth is there's a locking knob on the front of the saw right here. You're going to loosen that locking knob and you're going to pull down. And you can see right now that the saw is completely above that table. So then you'll just reverse it, pull it into position to where you want it, lock it down, whether it's 3/4 plywood, whether it's a 2x4 or 2x6. Okay? Then if you want to cut a bevel, there is an indicator scale here. You can loosen this little locking knob right here. And then what you do is you pull that base and then pick the degree that you want, lock it into place. And now you can cut a bevel. So you have 2 locking knobs there. When you cut this bevel, what you're going to have to do is you're going to have to raise this guard up. The reason being it's such a steep angle that the guard digs into the wood and it'll throw your saw sideways. If your saw goes sideways while you're cutting, what happens? Pardon? Kickback. It'll bind up, most likely kick back at you. So what I do is I will hold that up just as far until I can let go and it rides on the surface of the material that I'm cutting. Okay, because you do want to keep that guard activated for safety. Okay. So that's how to adjust it on the direct drive saw. There's also a little knob right here, and that little knob holds, it looks like a little T, and what you do is you slide it in. It slides in here, and then you lock it down, and it's like a little mini fence. And that little mini fence will help you do ribs probably up to 8 inches or so. We have table saws, and so I don't even think you could find one of those little T's anywhere on the job site. Okay, so we have wonderful table saws. We're going to have to use that as more safe. You guys at home may not have a table saw handy. You could use that if you're making some little ribs on a long distance. Okay, the worm drive. It has locking levers. There's a locking lever right here. And that is if you want to cut a bevel cut. Just roll this over. Now I'm going to hit a 45. And then reverse it, lock it down. Go this way, you lock it down. And now you're cutting a 45. Remember, the indicators on here, they're only so good. It may be a 45.5. Okay, you might have to engage a little bit further or a little bit less, just depending on. So the way to do that is make a sample cut and then check your sample cut to make sure you actually have the cut that you want. For depth, I'm going to set this back to cutting a 90. For depth, you have a Locking lever right here, you release that locking lever. Some of our saws are really, really stiff. This one's in pretty good shape. I just pull it, and I can lock that lever back into place. And now you have your depth, where I went just barely cutting. Okay. Some other features on the saw, the triggers, they're not a variable speed trigger. You pull the trigger, and you're going to get the full speed. This one's 55 RPMs. This one here is 46 RPMs per minute. This one has worm drive gears in here. You look on the forward side, right up here, there's a worm gear system here, and what it does, it's kind of like your car that's an old standard car, going from first to third. Okay, first is a lot slower, and that's what this does. It has more torque, it has more power than the direct drive. Okay, and so that's why they did the worm drive system. This one right here is 15 amps. This one right here is 11.5 amps. So it's not even starting out at the same amperage. And definitely, this one has more power and more torque. It's way heavier, so some of you guys are going to make a decision on the weight of the saw, or you might make the decision of what saw you want to use on the idea that you're left-handed or right-handed. Okay. There's a strain reliever on here. This one's kind of in poor shape. We should probably take a little bit of electrical tape, put it around there. The strain reliever does a couple things. One is it directs the cord away from the tool, and then that way you don't cut the cord as often. Then also the strain reliever keeps the strain from pulling the electrical cord away from the attachments to the motor. Okay. Although you don't want to carry it around by that, okay, you don't want to overuse that strain reliever, you may do damage to the saw. With this saw right here, we talked about it this morning, you have what's called the brushes. And that's kind of a misnomer because today the brushes aren't brushes anymore. They're little blocks of carbide and with springs on them. And you have one on this side, one over here, and then you have one over here. And what that does, that makes the electrical contacts to the arbor, or the shaft that goes through there, and it hits those windings. In the old days, it was truly little brushes. How many guys have had little race car sets? Okay. And you have, some of them have little brushes, and some of them have like little pieces of metal that drop down on the track. And you got two because you got to have a positive and a negative counter. Okay. So there's the brushes, and you can replace those yourself. If you see a bunch of sparking going on inside here, these are the venting fins that are on this saw right here. If you hear some popping, or you hear see some sparking, or if it just doesn't run, it might mean the brushes are totally worn out. What you can do is take a standard screwdriver, unscrew that, and what you're going to find is, it looks like charcoal black. You're going to see like a little rectangle of carbide with a spring, copper spring, and a little coil attached to it. You probably get both of them for under $20, and you can put them in yourself, or you can have one of the repair shops here in town fix it for you. Okay, so just something to know for maintenance. Also, what I didn't talk about is on the worm drive, there is fluid inside here. And I think I did. It's 90 gear lube, 85, 90 gear lube that's in there. And you want to check it. And the way you check it, some of these have a window. And some of these, there's a little silver, it's a bolt head. And you take that out, and what they say is to put it on the table flat, like this, and then the oil should just come right up to the top of that. If not, you have to add a little bit. Okay. And you want to keep track of that because that's what keeps your bearings lubricated. This one has sealed bearings. It's a direct drive, so if it goes out, you just have to have the bearings replaced. Anyway, you will. Okay, on the handles for sawing. This one has like a D-grip handle that you hold on to. Okay, this one right here has that little locking knob out front that you can hold on to. You want to make sure your hands stay clear of the blade. If you're going to work on the blade, or you do the adjustments, you should have it unplugged. And both these saws are unplugged right now. Just trying to, we're getting pretty close to identification. If you drop one of these saws, it's probably going to damage something. Last year we had a student drop a saw and we had to replace the base. Those will run, the base actually is about 85 bucks. By the time you get it back, you're up to about $150, $140 for repair. Okay, the saws are about $250, so it's worth replacing, but try not to drop them. There's a little hook on the side of this right here. It's pretty handy. It's not for hooking on your tool belt. You better be a pretty big boy if you're going to carry this around on your tool belt. You can hook it on a sawhorse, on the lower part of your sawhorse, or you can hook it up in the rafters. Just make sure you hook it solid so it doesn't come down and hit someone. Okay, that's the design of that right there. I could hook it on right where Bodie's knee is. I can hook it there on a workbench. And the reason you want to do that is, for two reasons. One is you don't want to throw our equipment down in the snow and the rain and the muck. And then also, it's a little bit more strain on your back and your body if you have to reach all the way down to the ground. If all you have to do is lower your hand, lift up the saw, work, set it down, it's a lot easier on your back. And if you become a carpenter, and a good one, you're going to be tired at the end of the day. If you're making money, and you're making money for whoever owns the building and making. Okay, Mr. Lehman brought out a little battery. This one has about the same type. There's little locking knobs here. Loosen it, and you can tilt the base, making a bevel cut. Then on the side here, this one right here is to adjust for your depth. Loosen that up, and the base will move down. Right there. Then the on and off, you have this little button here on the side, and this little button right here. You can push it left, you can push it right, depending upon what hand you are. And that's kind of the safety, because once the battery's in here, the only way you can disengage it is take the battery out, or with this safety device, it has to be pushed before you're going to engage the saw. So if this was laying around, a little kid came up, and the battery was in it, hopefully he wasn't smart enough to push on that lock device right there. I believe it's a 19.2, and it looks like it's about a 5-inch blade, maybe a 5.5-inch little blade. And it's funny, because this little tiny blade probably costs 4 times as much as this blade right here. Just because this is the old standard and they produce these by the millions, and they probably only produce these not too often. Okay. If you look at the cord, this one has a 25-foot cord on it. This one here probably has about 8 or 10 foot cord. Why would you want a longer cord? Yeah, give you more distance. Okay? And the key, too, is that when you make your connection, like with an extension cord, it seems inevitable that when you go to climb the ladder, you want to make a cut, it hooks on the ladder one. Whereas if you have a 25-foot cord, it's usually laying on the ground, and you're able to make your cuts without having to drag the extension cord up with you. So it's pretty handy. If you look at these cords, it's a 3-prong. One prong is the white wire, one prong is the black wire, and then one prong is the green. The green would be the lower one, which is in Australian, they call it Mother Earth. It's an equipment ground. And it truly does go to a grounding rod that's driven into the ground. And it's equipment ground, so it would be attached to the aluminum housing of your equipment. Then if we look over here,